yeah, if you're going to write from scratch, what kind of language do you do? And these are just some pointers of things that I've come across, and so feel free to ignore them if you don't think it's true, but these are some of the things that, how I feel about writing fuzzers is that scripting languages usually are a lot better or easier because you can write less code and have the same thing that, the same thing that you would have in C code. To give you an example and come back to Scapy, is that the Microsoft bug where they had a bug in IP option parsing, and it was a proof of concept code public for that was a piece of C code, which was about 150 lines of C code, and in Scapy that's a single line of code. So and Scapy is written in Python, by the way, so that's one line of Python code basically. So scripting languages are really cool, and it goes a lot faster if you write stuff in scripting language usually. The other thing is obviously that, because scripting languages are generally slow, is that your fuzzing on itself will be slower. And one of the things I've noticed about Python is that it's really slow compared to like Perl or something. But you can optimize Python code, so that's good. Most people also recommend using scripting languages because it's just easier to write stuff. However, one of the things that I've kind of experienced is that these kind of scripting languages, they're really cool if you want to do like ASCII-based protocols and stuff like that. But if you've got stuff where you've got a lot of binary data, it gets kind of messy. I mean, like in Perl and Python, you've got to use pack and things like that. In C, you don't need those things. It's all native in C, basically. So if you're going to do a lot of binary stuff, it's probably not a bad idea to use C. Right. Besides all of that, if you don't like any of the languages and you want to write something in Dylan or Lisp or Smalltalk or whatever, go ahead. You should choose a language that you're comfortable with. But these are just some of the things I've come across. Right. So the other thing is smart fuzzers, or not smart fuzzers. Basically, you've got two kinds of fuzzers. You've got dumb fuzzers and intelligent fuzzers. And the difference is that with a dumb fuzzer is that usually it takes you between a couple of minutes and an hour or so to write one. So there, you can sit down, almost get one immediately, and just start fuzzing. The thing is that with dumb fuzzers, you usually don't know the specifics of a protocol, or don't want to know the specifics of a protocol or a file layout or some API, and you just you look at what's valid and then just change some things in there and pass it on to whatever you want to try and fuzz. That's shockingly effective. Honestly, I mean, like the Mangle stuff, which does pretty much the same thing, really took me by surprise. I never imagined that you could break IE and PHP and pretty much a lot of other stuff with it, but it does work. The one thing is with dumb fuzzers is that if there's going to be compression and encryption and checksums, that you're not going to get far. Building intelligence fuzzer is basically the opposite. You know the protocol and the file layout, and you're going to implement the fuzzing. You're going to implement the encryption and compression and checksums and whatever you need. So building intelligence fuzzers takes a while. Obviously, they'll be able to fuzz a lot more and go a lot deeper in a lot of code paths. So intelligent fuzzers almost always give you better results than dumb fuzzers. So it's kind of a trade-off. I mean, if you just want to go out and find one cool bug, then dumb fuzzers usually will give you good results. If you want to try and get complete code coverage, you probably end up building an intelligent fuzzer and spending a couple of days or weeks or even months developing one. So intelligent fuzzers take a lot longer to write, but they give you an awful lot of things, usually. Right. So some of the things that are interesting to fuzz, binary files, movie stuff, and all, lots of programs that interpret them, QuickTime, Real Player, Media Player, M Player, tons of stuff. And those are interesting. Say for executable files, the Mako and ELF and whatnot. Because you can pass those to a kernel, and if they kind of make a crucial mistake there, like let's say they take some link and they cause a heap overflow, whatever, that's a local root and that's a local kernel bug. So those are kind of interesting. Some more like like Office documents, like OpenOffice, graphic files, And another neat one is file systems, because, for example, on Linux, you've got like tons and tons of file system support. You've got, like with the exception of ZFS, you've got like JFS and UFS, XFS, Ricer, and about 20 other file systems. And all of these, the kernel has to like parse all these file systems, and there's lots and lots of things in there. When I had used the mangle tool over RicerFS, when I hit the enter button, I got a kernel panic. So lots of things that you can do there. Not binary files. You can, stuff like XML configuration files, those kind of things. You probably want to have smart fuzzers there, or at least take a known file that's known to be good, and then have something that's somewhat smart that can say, this looks like a string, so I'll change it into something smaller, or put %n or whatever in it. But usually you want to have some kind of intelligence where you're going to parse stuff that's not binary. Right. Yeah, more stuff to fuzz. You can fuzz, FTP protocol, obviously HTTP, DHCP, NTP, any protocol you can think of, you can probably fuzz. One of the interesting things about FTP is that you've got a lot of FTP fuzzers out there, but at least it looks to me that they're all exceptionally trivial. They take a list of the commands you can and give in the A and B, and some, the more advanced FTP fuzzers, they try some globbing bugs and maybe directed traversals, and that's good if you want to find bugs in tutor FTPD or something on Windows, which nobody uses. But if you want to, try and be serious about it and see if you can find some neat stuff in like Pro FTPD or something, you're going to have to look at stuff like race conditions, signal race conditions, because you can cause signals with that, like some timing issues. And nobody's ever looked at that with FTP fuzzing. It kind of amazes me, because my guess is that you're going to find a lot of cool stuff there. Right, so that's network protocols. APIs, system calls, are the obvious one. Graphic libraries are probably the also exceptionally obvious ones, because they're going to be parsing a lot of length fields and stuff like that. And you just got to get it wrong once, and bam, there's a heap overflow there or something. Right. So even more stuff to fuzz. SUID files, which is what I talked about in like the third slide or something. The where you can do like arguments, obviously, environment variables, signals, standard input, and for example, also open a lot of file descriptors, and then open 50,000 files, and then don't close them and call a suite file. And for example, if you do that in Solaris, you open 50,000 files, and you run the ping, you get a seg fault. And if there are any OpenBSD developers in the room, they'll probably go like, yeah, we know those kind of bugs. I hear some people laughing, so some people know what kind of bugs I'm talking about. But basically what happens when opening a lot of files is if you've got select loops and stuff like that, you've got something which is called an FD set array, which is a static array on the stack usually. And it usually can only hold like 1,000 or 2,000 files. Basically it's got 1 bit for every file set. So that means if it's got support for 1,024 files, and you've got 1,025 files open, it'll write 1 bit beyond that array. So those kind of bugs are pretty neat. And like on the BSDs, they fixed most of those. On Linux, they're pretty much not exploitable because of very strict R limits. But stuff like HP Unix and Solaris and a lot of other things, just if you open a lot of file scripts and run suites, 9 chances out of 10 you'll get some very interesting bugs there. So, and you can fuzz those things. I've never seen anybody do it, but that would be really interesting. And pretty much any input suite can take, and it's a lot of stuff, a lot of input. Right. So if you're going to write fuzzing tools, there'll be some things that you want to look at. Okay. Obviously, size fields. You want to look at strings, and then like things that terminate some kind of data, and things that mark its beginning. Right, so let's look at size fields. Obviously, one of the interesting ones is negative values. I'm sure you've all heard of it or seen some of those things, but they do cause a lot of problems. If you give me -1 in some stuff, that might cause problems. Some more examples. Stuff around like the boundaries, like where you get integer overflows, those are usually interesting, like 7f and then 08000, so some stuff like that. They can cause under-indexing, for example, negative values. They can also cause, if you just do a bound check and you store that stuff in a sign integer, and you check if it's bigger than some array, and then use that value to put in a copy loop, it'll get caused to do an unsigned integer, and very, very bad things happen. The other thing that is sometimes interesting is like if you've got binary protocols where you've got a length field saying the string that's coming is 10 bytes long, and then you've got a string there which is not 10 bytes long, but it's 20 bytes long. And then the program will be like, oh, it's 10 bytes long, that's okay. I'll just use string copy and copy that string into my buffer. So the length field's right, but the string itself is wrong. So these kinds of things, somewhat rare, but they do happen. So you should definitely, if you got these kind of protocols, you should look at that. Those things are interesting. The other one's obviously large positive numbers. They can cause, if you use them with multiplication, they can cause integer overflows. If they're by themselves unsigned, they can obviously cause integer overflows. Yeah, the last one, which is using very small numbers. And that might sound a bit odd, but all too often you see code like there where they've got the length which you control, and they've done some bound checking, like it's not bigger than or maximum value, and it's not smaller than 0, then it's okay. And then they come to this part and they say length, and at this part they're assuming it's bigger than 2 or at least 2, but you've given in 0 or 1, and basically you're under-indexing by a couple bytes. And for example, for string termination or something, and they'll add a 0 byte in there. And if you're under-indexing and this is on the heap, you've got a lot of problems. Right. So these are some of the size fields that you want to take into account. Right. So strings. Obviously, you want to have long strings, really long ones. Just in case somebody left a trivial stack smashes or some stuff like that in their code. This is kind of the classic. And then also format string bugs, you want to look for those. So you put some format string stuff in there. The thing I've seen, which is kind of odd, or at least a bit disappointing, is that a lot of the fuzzing tools out there that are going to fuzz for format string bugs, they're going to use 1 or 2 %ns, or they're going to use %s or something like that. That's not that good. It's not really a good idea to do it that way. What you want to do is you want to use lots of %ns. You want to use 15 or 20 of them. The reason is that if you use %s, even if you use 10 or 20 of them, if the stack is laid out just right, nothing's going to crash. If you're going to use %ns, even 3 or 4 of them, if the stack is laid out exactly right, I mean, it's kind of rare, but I've seen it happen. If it's laid out exactly right, 3 or 4 %ns, it's still not going to crash. And obviously you want to get it to crash. So, use 15 or 20 of them. And, it's almost guaranteed that it'll crash. I've never seen a stack that's that well laid out by accident. Another interesting thing in there is if you've got like strings and you've got some binary data in there, odd things might happen. You can usually, if you want to generate those, just grab stuff, get stuff out of def random or something. But if you look at the kind of C code that's there, this is very common code, by the way. It's exceptionally common code. Where basically you've got B is a string you control. You've just read it off the network, and you're putting it into this kind of thing. And go up to the first 0 byte, and then +1. You do memory location A, and then you scroll all the way over the array. Say as long as what's in B is equals to ASCII A, just increase B. And then after the loop, you want to jump over another one. What people forget here is that you should, in these kind of cases, check for 0 bytes, because if you don't, basically the string length was used will go until 0 byte, and then the second B++ will jump over to 0 byte and heap overflow. And this kind of code is exceptionally common. Right, so that's, right, more strings. Other things is like, when something expects a string, don't give it a string. Lots of null pointer references this way. if you got like single-threaded daemons and you got no pointer references, that's a denial, pretty nasty denial service. The other ones, like if you got lengths in ASCII values, that's pretty common. And basically just try to do keep the size things in mind and just use them in ASCII values. And this is fairly common. A couple of months ago, I discovered a bug in Ethereal where it does dis-CC parsing, which is distributed compiling. And it has an ASCII protocol where they say an argument, and then they say the length of my argument, and then they give you the argument. And the code basically just took the length, put it in the silent teacher, said, oh, it's smaller than my buffer. Let's give that length to memcopy, and there was a stack smash. Right, so that's kind of like, these are kind of like the strings that you want to keep in mind if you're going to look at stuff that's going to be written in C. Some more interesting things, which is usually more web-related, is SQL injection stuff. Though it's not always that, at least not related as in like forms or stuff. But for example, a couple of months ago, a friend of mine came across some commercial product which had a web server, and he connected to it with a fake browser, and he had SQL injection in his browser version, and it would trigger an SQL injection bug in this commercial product. So it's not always in like posting to forums and stuff. You can have SQL injection in other places as well, but usually it's in web-related forums and stuff like that. Yeah, cross-site scripting. I'm sure everybody's heard about them. Some JavaScript alert or something. So yeah, if you're into cross-site scripting and stuff, you can probably fuzz a lot of cross-site scripting stuff. A bit more damaging stuff is directory traversals. If it's like FTP stuff, you can usually get out of, like on Windows, or at least there have been a lot of them, you can get out of your chroot, something like that. In like web servers and stuff, it can get pretty nasty, because if you can do directory traversals, you might be able to get command execution from there. It kind of depends on the way things have been made. And then the last one of strings is command injection. Like backticks, for example, or semicolon or something like that. And every time I find one of those, it kind of amazes me that people still make these kind of bugs. I mean, you've got like some high-profile daemons and stuff out there where there's this kind of trivial command injection. You give it something that'll give to a shell as an argument, do backticks, and you get a remote root shell or something. Yeah. So these are kind of the strings that you want to look out when you're fuzzing. Right. Some more stuff. Basically, things that terminate or something, or that mark its beginning. You can have like no bytes or just 4 zeros, or brackets, stuff like that. And so basically, kind of things that you want to do is like not use them and just have it endlessly going on, for example, or put data that wasn't supposed to be off there anyway, and see what happens. If you can, like, if there are ways in the protocol to escape them, to escape some stuff, try to escape some of these things that mark some beginnings or endings. It can lead to surprising results. And then put several of those off each other and see what happens. Right. How do you want your fuzzer to actually work? The way I usually do is obviously you define some states of stuff that you want to do, and then I just use ran functions to decide what state I want to use, and then just fire that off, and that works pretty well. Usually, when you do these kind of things, you'll be working in endless loop. Yeah, some of the the random stuff, arc for random, and some more stuff. Def random and def urandom are exceptionally useful. Def random might not be that useful for fuzzing, because in fuzzing you want to do stuff very, very quickly, and it doesn't have to be cryptographically secure. So def random might not be that good, because it's slow. But def urandom is wonderful. If you're going to fuzz, it's like, you can't live without def urandom if you're going to fuzz. Or at least I can't live without def urandom. And it's usually an endless loop that you do these kind of things. The other thing is that usually, and this tends to be more towards fault injection, if you have very detailed analysis of what you're going to fuzz, and you've got that all written down, and you've got months of development, because these kind of sequential fuzz usually take a lot of time to develop. You've got a whole list of stuff you want to do, and you just have a for loop. You go from first test case till the last test case, and it just run down your list. And that's usually finite in time to do these kind of things. So these are usually two kind of things that you want to decide how you're going to fuzz stuff. Right. The other thing which is interesting in design fuzzing is that you're going to either mutate data or generate data. And mutating data is usually a lot easier because you take data that you know is going to be valid. If you've got a protocol, you sniff it and you say, this is valid because I've seen it work, it's valid. And you just put it in whatever you're going to fuzz and just mutate it. Keep it as much intact as it was, but change a few things in there and run it through. So data mutation is usually very easy to make, and it is amazingly effective. Yeah, it is. So the next one, data generation. This one takes longer because you have to figure out what you want to generate, and then still write code to generate it. So it takes a lot more time to program it, but you can cover a lot more code paths usually. Right. Some annoying things I've encountered while developing fuzzers is first of all, you've got bugs hiding behind bugs where one bug is so obvious that one bug is so annoying that it will always trigger on something, and you will not be able to trigger a bug behind it. So that one kind of sucks. There are a few cases where might be possible to get around the first bug and second bug, but because you're fuzzing, the first bug will always get triggered. So that one really sucks. User friendliness is it's really bad. Yeah, honestly, it's so annoying to fuzz some kind of program, and every time it gets a packet, you get a pop-up saying, this packet is invalid. I'm like, I know it's invalid. I want you to break, and usually it stops processing anything until you click OK. So it's kind of, user friendliness is really kind of annoying when you're fuzzing stuff. Yeah, memory leaks, arguably, you can say memory leaks are bugs or security bugs, but if it's like memory leaks, like 1 or 2 bytes every time, it's not that much, and you usually don't feel it, but they can get pretty annoying when fuzzing, because if you're spitting out lots of packets in an endless loop, every time you send out some kind of packet, it might leak 1 or 2 bytes. So after 5 million test runs, you've leaked 5 million bytes. And sometimes the leak can get bigger. So if you're going to be fuzzing something and it leaks a lot of stuff and sucks up a couple of gigs in a couple of minutes, you won't be fuzzing it for long. Right. The other thing is, programs that are slow in general, they're annoying to fuzz because you just have to wait a lot longer for your results. Usually, though, slow programs are interesting to fuzz because, if they're slow for what they're doing, because that means the programmer probably didn't know what he was doing, and that usually also reflects in the quality of his code. Like in terms of security. So they might be annoying to fuzz, but on the other side, they're also interesting because you just know there are going to be bugs there. And of course, you can only fuzz what's configured. If things haven't been configured, you won't be able to fuzz those code paths, obviously. And then the other thing, which is, I've talked about it before, but which is really annoying when you're fuzzing, is checksums, encryption, compression, all those things. Especially if it's compression or encryption that's not publicly known. It's not an open standard. It's stuff that you have to reverse engineer. That's pure hell. Right, so getting rid of these annoyances. Bug hiding behind a bug. If it's open source, track the bug down and just fix it. If it's binary, you're kind of not so lucky, because if you can track it down and patch it in the binary, depending upon what kind of bug it is, it might be trivial, but it might also be very hard. You might also be able, which I'll cover in the next one, but if it's binary, you might be able to, if you can isolate where it is, you might be able to preload it. The second one is user friendliness. That one's really annoying. You can usually preload stuff. If you get like a pop-up for something, preload it and just get rid of that pop-up. The other thing is that on macOS, you've got something which is called AppleScript. And what's so cool about AppleScript is, well, I'll show you that in the next slide. So, but keep in mind that AppleScript is really cool for helping you fuzz stuff. Memory leaks, which is basically, arguably a bug behind a bug, because memory leaks on themselves are bugs, I guess. Well, again, if the same rules for bug behind a bug apply, if it's open source, fix the memory leak if you can find it. If it's binary, if you can find it and if you can fix it, because binary is obviously a lot harder to patch than when you've got source code. But if you can fix it, try and fix it, because memory leaks do matter when you're fuzzing stuff. And then for like the other stuff, like slow programs and fuzzing what's being configured and encryption and stuff, there's usually no easy way to get around. Maybe configuration, maybe if you know what to configure, not what not. But all the other things, there's no easy way to get around them. You're just going to have to deal with them. So yeah, that really sucks. But getting around some user friendliness, specifically on macOS, you've got AppleScript, and AppleScript is sort of a programming language, but it looks more like English than a programming language. If you can see the code here, basically this is something I've used to fuzz Internet Explorer on macOS, and basically what you do is you tell application Internet Explorer, and then basically have a while loop in there, and then open a Gopher URL. And this is pretty cool because in Internet Explorer, you don't have to refresh when you're doing Gopher. You've got refresh in HTML, you've got no refresh in Gopher. And you could hit the refresh button a million times, but your fingers start hurting, or maybe they might even start to bleed, I don't know. But if you've got AppleScript, you don't need those things. AppleScript will do that for you. You'll tell AppleScript, do that what I would usually do, and it'll just do it. And besides the fact that you will save yourself a lot of pain in your fingers, it'll be faster because refreshing, you got human interaction, but this is just automated. So AppleScript's a godsend if you're going to fuzz stuff on macOS, but at the same time, it can cause problems because some applications on macOS, they either don't implement AppleScript and then you can't use it, or they've implemented really, really badly, so badly that when you try to write some AppleScript code, the thing will just crash when you're trying to communicate it with it. So, but besides that, AppleScript's really, really cool. Right. Determining how stuff fails, because it might sound a bit obvious, but sometimes it's kind of nice to have some pointers towards how these kind of things fail. Obviously, crashes, usually those are pretty easy to detect. But and I'll talk about that a little bit later and very small snippet on the next slide. Huge memory consumptions, they can usually be found with default tools, and I have a slide about that as well. Reboots, yes, usually you notice a reboot, so. Same thing with hangs, you can usually notice them. But yeah, that kind of depends what kind of hang, and because sometimes, sometimes you feel hangs, but sometimes you just don't. If you're not looking at the application specifically, you might not feel it in your operating system. It depends on the bug. Right. So crashes, yeah. This is kind of obvious, but it looks cool though, doesn't it? Right. So core attached debugger, and I'll be talking about debuggers quickly in a couple of slides. So that's basically, it crashed, and in this case, it's pretty easy to determine what's going on. Huge memory consumptions. This is from a real case, by the way. I was doing some fuzzing on Internet Explorer, and I made some bitmap fuzzing tools. And at some point, I came across some bitmap, and my mouse was hardly moving, and things were going very, very badly, and there was a huge load. So I hit Alt Control Delete, and I go to performance, and usually you see the page file usage history, and basically all my physical memory just was gone. Internet Explorer had just eaten all of it. So, and it's easy to see it here, and then at the the after picture, after Internet Explorer has died, after I've killed it, you see all the performance, it's all coming back. So it's kind of nice to see it in the graphical way. But usually it's easy to detect these kind of things. Yeah, a reboot. A while ago, I was fortunate enough to be at be at a friend's place who had a Cisco, and I figured, I've never fuzzed a Cisco before, so let's do that. And this was the result I got. I haven't played with it before because I know very little about Cisco devices, but it was fun though to see it break, and then you get some stuff in there, some registers, and then Cisco realizes it has crashed and it reboots. So it's kind of neat to see those kind of things. But hangs is, it's another Internet Explorer thing. Basically, if your CPU memory usage for some application never drops until you kill it, something's up. Right. So seeing more than just a crash. This is just a couple of pointers. I really don't have time to go into detail on any of these things, but if you're interested in some of these things, you should stick around for next talk by Richard. He'll be giving you a really cool tour of some of the things in IDA Pro, which I mentioned here, and how you can figure out some structures of binaries and how you can use those for fuzzing, for example. If you're fuzzing something, try to attach a debugger. You've seen GDB, but the thing about GDB is that it's not really that wonderful. I mean, it's nice if you have your code compiled with debug and all these kind of things, and you've sprinkled some printfs around and things like that. But if you're gonna fuzz things that will create threads and that will fork and that will call the execute system call, GDB is kind of bad because GDB can't handle threads that well. It basically breaks on a lot of thread stuff. Execute system call is just as bad. Fork kind of depends. If you're lucky, it doesn't. It does work. If you're not lucky, it doesn't. Auto debug is one of the Windows debuggers. It's pretty neat. I've looked at some of that stuff. Pretty cool. WinDBG is sort of like AutoDBG, but it's made by Microsoft. Softice is kind of like one of the huge debuggers in Windows. It's a kernel debugger, and if something breaks, you can get it to pop up. So this is just some of the debugs that you might want to look at. Disassemblers can also be helpful if you fuss something and you've got an idea where it's gone wrong, but you don't know exactly what's gone wrong. You can fire up your disassembler and look at the entire program or large parts of the program. IDA Pro is obviously, I mean, this one's kind of unfair because like IDA Pro is like the disassembler. There's not a single one that's better probably than IDA Pro. And Object Dump as well. It doesn't really compare to IDA. Object Dump is a really, really simple tool. Sometimes Object Dump is useful. Usually it's not that useful though. IDA Pro is amazingly cool. You guys should, if you want to know some more about IDA, you should definitely stick around and see Richard's talk. Right. Yeah. The thing is that you should, when you're debugging stuff, try to keep track of everything that's forked and spawns that have been threads that have been spawned. Excuse me. If you're using GDB, you're kind of out of luck because GDB will probably crash on some thread stuff. Right. Some more utilities. For Unix, you've got strace and ltrace. strace will give you some nice information for system calls that we used, and ltrace does pretty much a similar thing, but for system calls. And on Windows, you've got a tool that FX developed, which is Dumbug, and it can do similar things. The other thing for seeing more than just a crash is looking at your log files. If you see something like that in your log files, something's up. Somebody tried some kind of format string bug, and apparently they succeeded, at least in triggering it. Right. Okay. Extending existing fuzzers. That's one of the things that you should definitely do, because the thing with, for example, the Mangle.me tool from Mikhail Zalewski is that it was just scratching the surface. It only fuzzed a small part of HTML, and it didn't even cover anything else that the browser did. So if you just take any fuzzer that anybody ever made, just take it and look what it does, and then think about things they've forgotten. If you implement those, and then just run your tool against whatever they ran it before and all the bugs they fixed, just run it again, and I can almost guarantee you that you'll find new things. You don't always have to start from scratch. Just take other people's work, build upon it, and usually you find new things. Another example of this is, and this is actually a good one, is the Protos, the SIP fuzzing tool they had. They've spent months trying to figure out exactly where things can go wrong, and they've worked things out in detail. And so they've covered a lot of code paths and a lot of devices or software that parses SIP. And so they've probably, if you run something against Protos, you can catch most of them. But then a couple of months ago, somebody discovered a bug in Ethereal in SIP parsing. And this was one of the main attributes of SIP. And the actual bug in Ethereal was a trivial string copy where you had a stack smash and buffer overflow 101. But the thing is, because the guys from Protos had run their tool against Ethereal, and they discovered several bugs in the SIP parsing, but they had missed a specific one. So if you had taken the RFCs and look at the way people implement stuff, and you would have extended Protos for this thing, you would have been able to find that particular bug in Ethereal. So even if people have put a lot of thought into developing fuzzers, even if they spent months developing a fuzzer and putting a lot of hours into that, they'll still have missed some things that you might think about. Just implement it, run the tools again. Usually you find cool stuff, right? So my conclusion, because I know you're all bored of me and you want to go out, but my conclusion is that fuzzing is amazingly cool. And even if I sound boring to you, you should still go out and try some fuzzers, because it's like, you have to experience, you just have to experience fuzzing and see what it's all about and get this warm, fuzzy feeling the first time you break something. But fuzzing is amazingly cool. Also, if you compare the amount of stuff that you can find with fuzzing in a time frame, and then see how much time it would take you to do a code audit and come to the same conclusions, it'll probably be like a factor of 10 or something. I'm not saying that you should get rid of code audits and only do fuzzing, because there are some tools some bugs that are hard or pretty much impossible to fuzz that you might be able to find with code audit. But if you're just out to find a couple of bugs, fuzzing will save you a lot of time. I spent the last about 2 years doing an unhealthy amount of code auditing, and then I discovered fuzzing. It was like a whole new world opened for me. So you can find a lot of cool things in a short period of time with fuzzing, where it would otherwise take you days or weeks or months or even years when doing code audits. And fuzzing is probably the most widely used method of finding bugs these days. And of course, the final conclusion, the coolest one, is that people cannot write decent parsing code. Right, and this is, okay, some advertisement. There's a magazine called MISC, and there have been some of these around. I think there have been, the guys from MISC bought like 600 of them with them here. And it's a magazine about computer security. And this started off in France, and in France I think they're up to issue 22 or 23. And since a couple of months they've got MISC magazine here in Germany. And issue 3 contains an article about fuzzing, which a friend of mine made, and he's covered some of my things. So you should definitely check out MISC, it's really cool. Although I don't know exactly what's in it because I don't read German. But I've talked to some of the editors, and they've told me that it's a really cool tool. Magazine, yes, okay. Right, so some interesting links, and this is basically where I'll shut up then. The first one's Violating Assumptions with Fuzzing, which is a paper written by 2 people at Microsoft, Michael Howard and another guy whose name I've forgotten. And basically this is their experience that they've had throughout a couple of years at Microsoft doing fuzzing, and some of the things that they've noticed doing fuzzing. And there's a lot of cool stuff in there. If you get your hands on that paper, if you're at a university, you can get it for free. If you're not at a university, you have to pay IEEE 20 euros to get 5 pages of text. So, or if you're smart, you'll just bounce from some university and get it for free anyway. I wasn't that smart. I actually paid them $20 because I didn't know I could bounce off universities. But so if you're smart, you're not at university, just bounce over some and just get it for free. But that paper's pretty neat. The next one's basically the talk that Dave Vitale gave at Black Hat in 2002 about Spike. You should definitely look at it. If you're interested in Spike, those slides are a good starting point. The next one is slides from a presentation that FX made, which I really, really like. And basically, at least from what I understood, that the slides or the talk was meant to show people that hacking is really hard work, although it's really fun. It's a lot of work, and it covers more than just fuzzing. It covers fuzzing, adding statistical analysis and doing binary analysis, and then it also covers the exploit development and the making exploits reliable, and then something like don't use C because C takes too long to develop stuff in. So, but that one's really cool. It gives you a more complete picture. Right. The next one's a talk of two guys from iDefense who talked at Black Hat this year about file fuzzing, and that one's interesting too. If you've got some time, definitely check it out. Then there's the talk from Brett Mounet, I think that's his name, from at Stake at the time, discussing Combust and how cool it really is. And if you manage to read that PDF, you'll see how cool the configuration options are in Combust. And then obviously, some advertising for myself. That's my website, and you can find some of my fuzzing tools there. And I've got a collection of fuzzing tools that other people made that you can find there. And I've made some slight modifications to some things that people made because I thought some things were off or wrong or they missed some stuff. And you can find them all there. If you're interested in fuzzing, or if I've got you all hyped up for fuzzing, you should go there, and there's some cool stuff there. The one under that is Advances of Block-Based Fuzzing, which is where Dave Vitale explains to people who read it how cool block-based fuzzing is and why not using block-based fuzzing sucks, or why it sucks according to him. The last one's about a talk that Matthew Franz did, Black Hat, in 2003, covering this PIF tool, Protocol Independent Fuzzer. And basically, the tool's more about showing people how good or how bad BGP is these days in terms of security. Right. That's about it. Any questions? Nope. No questions? Okay, that's good. Saves me time. Thank you.